The pull-stud bolt is the only part connecting the machining center and the tooling. It is one of the most important components because this one bolt retains the tooling and it must stand up to severe cutting forces. Because the pull-stud bolt is used under severe conditions, it is regarded as a consumable item. This is why regular inspection and exchange is essential. However, in some cases, pull-stud bolts are used without regular inspection. And because of the lack of inspection, it may cause damage. Pull-stud bolts suffer from clamping and unclamping during each automatic tool change, as well as cyclical forces caused by vibrations during cutting. This cutting load can be the cause of breakage from fatigue. To prevent failure or breakage caused by fatigue, generally speaking, pull-stud should be replaced every 2 years. However, depending on operating conditions, this time frame may be shorter. There are 2 different methods of clamping a pull-stud bolt. One method uses a collet and the other uses a ball lock system. In the case of the collet type, the collets and pull-stud bolt have face contact. With the ball lock type, the pull-stud bolt has only point contact. The ball lock type retention can cause dents on the pull-stud bolt and tends to shorten the useful life. In production applications with very short cycle times, frequent tool changes can shorten the pull-stud bolt life and require more frequent replacement. In some cases, the pull-stud bolt may need to be replaced every 6 months if frequent tool changes are done with a ball lock type machine. There may be rare occasions where corrosion may be an issue. Coolant type, its management, and the workpiece material may cause this problem. Water-soluble coolant is generally alkaline in order to avoid rust and corrosion. However, during long-term use, such coolant can become acidic and increase the rust and corrosion inside the coolant tank, on the machine table, the work material, or in other parts of the machine. The same can be said for pull-stud bolts. With the increase of rust and corrosion, its integrity decreases and can lead to fracture. In the machining of free-cutting steels, the included sulfur components may be transferred to the coolant. Sulfur can corrode metal and may accelerate corrosion. Though it is rare, if the rust and corrosion of the machine, workpiece, and tooling are evident, such corrosion may reach the pull-stud bolt. We recommend regular inspection and replacement. Make sure to tighten the pull-stud bolt properly so that it does not vibrate loose during cutting. After cleaning and degreasing the thread, apply a thread lock adhesive. Tighten it to the appropriate torque. To use pull-stud bolts with security, proper use, regular inspection, and exchange are important. In addition, the quality of the pull-stud bolt itself is important. Biggs pull-stud bolts are scrutinized for both dimensional control and material. Both hardened alloy steel and die steel are used depending on the application. As die steel is 2 times stronger than hardened steel in tension and 1.5 times in bending, you can use it for additional security. Regularly inspect the pull-stud bolts for possible trouble and choose one with reliable quality for safe and secure production.